Hello my dear students, this is the last lecture in this term. This lecture is calcium homeostasis and related diseases. What is meant by calcium homeostasis? Calcium homeostasis means control and the regulation of calcium level in the serum. Serum level of calcium can be controlled by three main hormones, which are calcitonin and parathyroid hormone and vitamin D. These three hormones are essential in controlling calcium level in serum. These three hormones can control calcium level and its principal counter ion phosphate. Homeostatic control of these ions, which are calcium and phosphate, is essential not only for the regulation and longitudinal bone growth and bone remodeling, but also they are essential for regulation of other physiological functions in the body like blood coagulation, neuromuscular excitability, plasma membrane structure and function, muscle contraction, glycogen and ATP metabolism, neurotransmitter hormone secretion, and enzyme catalysis. Now we will talk about some diseases associated with abnormal calcium homeostasis. We will take the first disease, which is osteoporosis. What is meant by osteoporosis? Osteoporosis is a skeletal disease that is characterized by loss of bone mass as well as deterioration of the bone tissue. This image shows the difference between the normal bone and the osteoporotic bone. In osteoporotic bone, here there is loss of bone mass. Also, there is deterioration of the bone tissue. Osteoporosis is associated with increased bone fragility and susceptibility to fracture. Even patients with osteoporosis, when during sneezing or sudden movement, this may lead to break down to the bone in the patient with severe osteoporosis. We have three types of osteoporosis. Type 1 osteoporosis or post-menopausal. This is an accelerated rate of bone loss via enhanced resorption at the onset of menopause. What is the meaning of resorption? It is a process through which there are certain cells in bone tissues called osteoclasts. These osteoclasts are responsible for breaking down of bone cells and release calcium into the blood. Osteoclasts again are responsible for bone breaking of bone cells and release calcium from bones to the blood. There are other cells called osteoblasts which make the opposite process, in which these osteoblast cells take calcium from the serum or from the blood and responsible for building of bone tissues. So we have two cells in the bone tissues, which are osteoclasts and osteoblasts. Osteoclasts are responsible for breaking down of bones and release of calcium into the blood, while the osteoblasts make the opposite process, which takes the calcium from the blood and make new bone tissues. Another type of osteoporosis is type 2 osteoporosis, which is associated with aging. Type 3 osteoporosis, which is drug or disease induced. In type 3 osteoporosis, there is inhibition of calcium absorption from the intestine or from the gut and excessive loss of calcium in the urine. This is due to disease-induced or drug-induced. Disease-induced osteoporosis, some diseases like estrogen deficiency, hyperparathyroidism, hyperthyroidism, hypogonadism, and renal diseases. These diseases cause inhibition of calcium absorption from the gut and excessive loss of calcium in the urine, causing type 3 osteoporosis. While the drug-induced osteoporosis, some drugs causes osteoporosis, like treatment with glucocorticoids, treatment with thyroid hormones, treatment with anticonvulsants, or with methotrexate. These drugs may lead to inhibition of calcium absorption from the intestine and excessive loss of calcium in urine, causing osteoporosis. Now we will talk about the drugs. Here we will start the medicinal part in this lecture. We will talk about drug therapies used to treat osteoporosis. These agents are classified as anti-resorptive agents or bone restorative agents. Anti-resorptive agents, in order to stop the resorption process, stop the breakdown of bone cells, and stop the release of calcium from bone tissues into the blood. The first therapy, which is estrogen analogs or estrogen replacement therapy. This therapy is beneficial in or drug of choice in treatment of osteoporosis type 1 or postmenopausal osteoporosis. As estrogen improves calcium absorption, also estrogen promotes calcitonin biosynthesis, which is responsible for reducing calcium resorption. Hormone replacement therapy is the treatment of choice for osteoporosis type 1 or postmenopausal osteoporosis. Estrogen replacement therapy, like 17-beta estradiol, estrone sodium sulfate, or 17-ethinyl estradiol. This estrogen replacement therapy is classified as anti-resorptive therapy, as it stops the resorption of bones and stops the release of calcium from bones into serum. This is essential in treatment of osteoporosis type 1 or postmenopausal osteoporosis. Also, estrogen replacement therapy is available in several formulations. The most important one is the transdermal patches, as these patches have slow onset of action and also long duration of action. Estrogen replacement therapy is initiated at the onset of menopause and continued indefinitely with the patient. This therapy, which is the estrogen replacement therapy, has additional favorable effects on serum cholesterol levels, as they can reduce the bad low density lipoprotein levels and elevate the good high density lipoprotein levels, and has been shown to decrease the risk of cardiovascular diseases by 50%. From the estrogen replacement therapy, we will take selective estrogen receptor modulator, and its abbreviation as SERM, or selective estrogen receptor modulators. We will take an example from it, which is raloxifene. Raloxifene is selective estrogen receptor modulator. Also, it is benzothiophene derivative. This ring is benzothiophene derivative. So, raloxifene acts as an estrogen agonist on the estrogen receptors that is present in osteoblasts and osteoclasts, but in the same time acts as antagonist on the estrogen receptors that is present in breast and in uterus. When raloxifene acts as estrogen agonist on the estrogen receptor in the osteoblasts, making the number of osteoblasts increased. These cells, as we said before, these osteoblasts are responsible for building new bone tissues as they take calcium from the blood and use it in building new bone tissues. And when they act as agonists on the estrogen receptor that is present in osteoclasts, making the number of the osteoclasts decreased. As we said also before, osteoclasts are cells that is responsible for breaking down of bone tissues and release calcium from bones into blood. So, raloxifene acts as estrogen agonist in osteoblasts and osteoclasts, making the number of osteoblasts increased and the number of osteoclasts decreased. Also, raloxifene acts as an antagonist on the estrogen receptors that is present in breast and in uterus. This selectivity in its action helps in decreasing the risk of endometrial or breast cancer. Raloxifene shouldn't be administered in combination with cholestyramine. Cholestyramine is a drug which is used in treatment of hyperlipidemia and in treatment of certain diarrhea cases. As when raloxifene is administered in combination with cholestyramine, this leads to decrease in absorption of raloxifene. Also, raloxifene shouldn't be used with drugs which are highly protein bound, like clofeprate, diazepam, ibuprofen, indomethacin, and naproxen. These drugs are highly protein bound, and this leads to decrease in absorption of raloxifene and affects its action. The second drug for treatment of osteoporosis is the biphosphonates. Biphosphonates are synthetic in origin. Biphosphonates are used in all types of osteoporosis, not only post-menopausal osteoporosis, but biphosphonates can be used in treatment of all types of osteoporosis. Biphosphonates are synthetic in origin and they are designed to mimic the pyrophosphate. What is pyrophosphate? This is the structure of pyrophosphate. Pyrophosphate is a normal constituent of the bone. Biphosphonates, we replace this oxygen atom by carbon atom. Why? In order to create a non-hydrolyzable backbone. When there is carbon instead of oxygen, the drug become stable and not easily hydrolyzed. So, biphosphonates mimic the structure of pyrophosphate. Oxygen is replaced by carbon. What is the mechanism of action of biphosphonates? Biphosphonates inhibit osteoclast proliferation, so this leads to decrease in the number of sites along the bone surface where bone resorption occurs. What is structure-activity relationship for biphosphonates? As we see, pyrophosphate mimic the structure of biphosphonate, except this oxygen atom is replaced by this central carbon. This central carbon has two functional groups. The first functional group, which is R1, R1 is hydroxy OH group. It is constant in all biphosphonates. These hydroxy substituents maximize the affinity of the drug as well as improve the anti-resorptive character of the drug. While R2 differs from one drug to another. R2 affects the potency of the compound, and according to the type of R2, different generations of biphosphonates are generated. First generation, second generation, and third generation, according to the type of R2. R2 also is responsible for certain molecular interaction with the receptor. Here, the structure-activity relationship is discussed. Here, the pyrophosphate and the biphosphonate. The biphosphonate, as we said before, this central carbon has two functional groups, R1 and R2. R1 is OH in all biphosphonate derivatives. R2 Here differs from one drug to another. R2, when it is alkyl amino substituted biphosphonate, becomes second generation, like bamidronate and alendronate. R2, when it is alkyl amino substituted, it becomes second generation biphosphonate, are more potent than the etidronate, which is the first generation. When R2 is methyl, as in etidronate, this R2, when it is methyl, become less potent than the alkyl amino substituent. So again, when the R2 is alkyl amino substituted, it is more potent than the methyl substituted etidronate. In R2, when it is 4-carbon amino linear chain, as in alendronate, becomes more potent than the 3-carbon derivatives bamidronate. As the chain length increase, the activity and the potency increase. In the third generation biphosphonates, there is basic heterocyclic side chain, as in residronate. There is pyridine ring linked to this carbon atom by a linker or by a spacer. When this spacer or this linker is N, become more potent than C, become more potent than S, and more potent than oxygen. We will take from the third generation biphosphonate drug, which is residronate, as we see in the next slides the structures. Here we will study the first generation biphosphonate, which is etidronate. As we said in the previous slide, this central carbon has R1 and R2. R1 is OH, which is constant in all biphosphonate derivatives. R2 here is methyl. This is the first generation etidronate, and the rest of the structure is the same. This etidronate drug used in treatment of Beckett's disease and in osteoporosis. What is Beckett's disease? Beckett's disease is a disease which is characterized by excessive bone resorption, followed by replacement of the normally mineralized bone with soft and poorly mineralized tissue. So, etidronate is used in treatment of Beckett's disease and in treatment of osteoporosis. But etidronate has main disadvantage. It is only used for short time, for 2 weeks every 3 months. It cannot be used for a long time. Why? Because if it administered on a continuous basis for a long time, it may prevent bone calcification. So what is the disadvantage of the etidronate? This disadvantage is it cannot be used for a long time. It is only used for a short time. In order, if it is used in a long time, it will cause prevent bone calcification. We have finished the first generation biphosphonate, and now we will talk about the second and the third generation biphosphonates. The second generation biphosphonates, like bamidronate and alendronate. As we said before in the structure-activity relationship, as the length of the side alkyl amino side chain increase, the potency increase. In the alendronate, there is 4 carbon atom spacer, 1, 2, 3, 4. While in bamidronate, there are 3 carbon atoms spacer only, 1, 2, 3. So as the length of the side chain, carbon side chain increase, the potency increase. So alendronate is more potent than bamidronate. Both bamidronate and alendronate can be used in treatment of osteoporosis and used in treatment of Beckett's disease. Now, the third generation biphosphonate, as we said before in the SOR, like residronate. Residronate has a pyridine ring, which is attached to this central carbon by a linker or by a spacer. This linker is CH2. This residronate is a third generation biphosphonate. It can be used in treatment and prevention of osteoporosis. Also, it can be used in Beckett's disease. Here we have finished our term. Wish you all best of luck. Thank you very much, my dear students.